There was once an adrenaline junkie who looked back on his life with fondness. Back in his younger years, he pushed the boundaries of snow machining and encouraged all to embolden themselves while out on their sleds. Early in his career as a professional rider, he made a name for himself through stunts and tricks like these. He rode uphills, downhills, did the whole jumping thing, and even flipped once or twice. People talked about him across the globe. He was a sensation. And then he grew old. As an old man, Deegan loved to show off his white beard and his classic sled. He often spoke of his daredevil days, but he was peaceful now that his life was balanced out a bit. It was all about balance. One-step equations are equations with variables. You have to do only one step to solve. These pictures give us a hint of what we need to do to solve the equations. So this first picture here shows that you need to do something upside down. So that would be the inverse operation. The inverse operation of addition is subtraction. Remember, equations need to be in balance, like these rocks are in balance and the scale shows a balance. So you have positive 3 right here. So you need to subtract 3 on both sides of the equation. Keep it in balance by doing the same work on both sides. These 3's cancel and x equals 2. Now put it back into the original equation and see if it makes sense. 3 plus 2 equals 5. Yeah, it makes sense. For this problem, we'll subtract 12 from both sides. Sometimes I like to put a line here to show that things are in balance. These 12's drop. X equals 7. Put 7 back into the original equation. Does it work? Yes, it does. Subtract 5 from both sides. Now remember, this 7 here, this negative 7, it's already negative. It's already down the line on the number line. Here's 0. Here's negative 7. So if you're going 5 more negative, you're going to be at negative 12. So for this problem, x equals negative 12. And then put negative 12 in and see if it makes sense. Negative 12 plus 5. Does that equal negative 7? Yes, it does. There's a positive 6 here. Subtract 6 from both sides. These 6's drop. X equals 4. Put it back in. 6 plus 4 equals 10. Yes, it does. Subtract 7 from both sides. X equals 5. Put 5 back in. It does make sense. Subtract 4 from both sides. These drop. 10 is already negative, so it's going to become more negative. X equals negative 14. Put it in. Negative 14 plus 4, does that equal 10? Negative 10? Yes, it does. Okay, all of the problems on this screen have something that's negative. Either we need to subtract it or it's negative. So here is minus 3 and subtract 12 and minus 5, negative 6, minus 7, and minus 4. So to get rid of all of this negativity, all of this subtraction, we need to add. We need to keep it in balance by adding 3 to both sides. X equals 8. These 3's drop. Put it in and see if it makes sense. Negative 3 plus 8, does that equal 5? Yes, it does. Add 12 to both sides. These drop. That's going to be 1. X equals 31. Put it in and see if it makes sense. 31 minus 12, does that equal 19? Yes. Add 5 to both sides. X equals negative 2. Put it in and see if it makes sense. Negative 2 minus 5 is negative 7. Yes. Here's 0. Here's negative 2. Minus 5 more, you get down to negative 7. Let's add 6 to both sides. X equals 16. Put it into the original equation. Negative 6 plus 16, does that equal 10? Yes. Add 7 to both sides. These drop. X equals 19. Substitute 19 into the original equation. Does it make sense? It does. Add 4 to both sides. These drop. X equals negative 6. Put negative 6 into the equation and see if it makes sense. Negative 6 minus 4 equals negative 10. Yes. Remember, here's 0. Here's negative 4. And if you're going negative 6 more, then you end at negative 10. All of the problems on this screen have something being multiplied by a variable. So in this problem, negative 3 is the coefficient, and it's times the variable x. Negative 3 times x. So we need to do the inverse operation, like this dude's doing an inverse flip. We need to do the inverse operation of multiplication, which is division. So divide by 3, negative 3 on both sides. You want to make the negative go away also. So x equals, well, what's negative 15 divided by negative 3? It's 5. Now check it. Negative 3 times 5, does that equal negative 15? Yes. Divide by 4 on both sides. X equals 9. Put it in, see if it works. 4 times 9, does that equal 36? Yes. Divide by negative 8. X equals negative 5. Put it into the original equation and see if it makes sense. Negative 8 times negative 5. Does that equal 40? Yes. Divide by negative 6. X equals 2. Substitute 2 in for x into the original equation and see if it makes sense. Negative 6 times 2. Does that equal negative 12? Yes, it does. Divide by 5. X equals 7. Substitute 7 into the original equation. 5 times 7, does that equal 35? Yes. Divide both sides by negative 6. Keep things in balance, just like Deegan kept things in balance. X equals negative 6. Substitute negative 6 into the original equation. Negative 6 times negative 6, does that equal 36? It does. All of the problems on this screen have the variable being divided by some number. So again, we need to do the inverse operation. The inverse operation of division is multiplication. So we need to multiply by whatever the denominator is, and that will help us isolate the variable. In this first problem, you have x divided by 6, but then the whole thing is negative. So we want to take away the division by 6, and we want to take away the negative sign. So we're going to multiply everything by negative 6. That means both sides. These 6's cancel, these negatives cancel. X equals negative 72. Now put negative 72 into the original equation and see if it makes sense. Negative 72 divided by negative 6. So the negative divided by the negative cancel. 72 divided by 6 is 12. That works. In this second problem here, x is being divided by 4. So let's multiply everything by 4. When I say everything, I mean both sides. Remember, you have to keep it in balance. Just like these rocks are in balance, keep your equation in balance. Divide by 4 times by 4, they cancel. X equals 4 times 4 is 16. Substitute 16 into the original equation and see if it works. Put 16 right there. 16 divided by 4, is that 4? Yes. Multiply by negative 3 on both sides. Remember, the floating dot means multiply. These cancel. The divided by 3 cancels the multiply by 3, and the negatives cancel each other as well. x equals 18, because negative 6 times negative 3 is 18. 18 divided by negative 3 is negative 6? Yes. Multiply everything by negative 5. These cancel. X equals negative 50. Negative 50 divided by negative 5 is 10. Multiply everything by 7. These cancel, and you've isolated your variable, and you get 56. Substitute 56 into the original and see if it makes sense. 56 divided by 7 is 8. Yes. Multiply by negative 9 on both sides. These cancel. X equals 18. Everything on this page has to do with a fraction. Here's the rule. When you have a fraction in front of a variable, multiply by the reciprocal on both sides. The reciprocal is the flipped fraction. Multiply, and for this first one we want to get rid of the negative as well. So we're multiplying both sides by negative 6 over 5. All of this cancels. X equals, this cancels to get a 3, and this will be a 1. Negative 18. See if that makes sense. Negative 18 times negative 5 over 6. The 6 and the 18 will cancel. That'll be a 1. That'll be a 3. And then you'll have negative 3 times negative 5, and that equals 15. So for that problem, negative 18 is your answer. Multiply both sides by 7 over 6. Keep it in balance. You'll do just a little bit of cross-canceling. First of all, the left side cancels completely. And then the right side we can cancel and get 8 here and 3 here. So we have 56 over 3. Multiply both sides by the reciprocal, negative 9 over 7. Multiply by negative 9 over 7. All of this cancels. The 7's cross-cancel, the 9's cross-cancel, the negatives cancel. X equals, so put 1 there. It looks like there's no cross-canceling, so 18 times 7. 6 and 5. 7 plus 5 is 12. Negative, oh, the negatives cancel there also. So for this problem we'll have 126 over 7. Need to clean off some space just a little bit. Multiply by negative 5/3. All of this cancels. Put a 1 there. The 3 cancels to a 1. That cancels to a 4. 4 times negative 5 is negative 20. Multiply by 4/3 on both sides. All of this cancels. You've isolated your variable. 9 turns into a 3, and the 3 cancels to a 1. 3 times 4 is 12. So see if it makes sense. 3/4 times 12, is that 9? 3/4 times 12, is that 9? So there's 1 there, and there's 3 there. 3 times 3 is 9. Yes, it works. Multiply both sides by negative 3 over 2. All of this cancels. X equals 7 times 3 is 21. 1 times 2 is 2. Those negatives cancel, so you're left with 21 over 2. Remember, when you have a one-step equation, it takes one step to figure it out. It could be addition, subtraction, multiplication, or division, and the inverse operation needs to be applied. The inverse operation of a fraction is multiplying by the reciprocal. Thank you.